Physics continue பண்ணலாம். Properties of solids பார்த்துட்டு இருக்கோம். Okay. So அதில் last topic வந்து Hooke's law and its experimental verification. Hooke's law and its experimental verification. So Hooke's law na என்னன்னு ஃபர்ஸ்ட் பார்க்க போறோம். அதுக்கு அப்புறம் அதை எப்படி எக்ஸ்பெரிமெண்டா வெரிஃபை பண்றோம் அப்படின்றதையும் வந்து நம்ம பார்க்க போறோம். Okay. So first வந்து Hooke's law. I will write the law first, then you can write. Hooke's law is for small deformation. Deformation means when the shape is changing. When a small shape is changing, okay, it is Hooke's law is applicable for a small deformation. Okay, so Hooke's law states that the stress and strain for a small deformation, stress and strain for a small deformation are proportional to each other. This is only called as Hooke's law. So stress is proportional to strain. Okay, that is only called as Hooke's law. So we can write stress is proportional to strain for a small deformation. Okay, so experimental verification of Hooke's law. Experimental verification of Hooke's law. So for this you have to draw a diagram. This is the support, this is the wire, this is the pointer, this is the band, the weight is kept in the band, this is the scale. Okay. So you know, when you keep the weight, what will happen to the wire? It will stretch. Okay. So that stress and strain only we are going to prove that it is proportional. Okay. So first we have to explain this experimental setup. Okay. So write down. I will dictate the notes point wise. You write the first point. A thin straight wire. A thin straight wire, inside the bracket you write stretches like a spring. This is a very important question. Okay, Hooke's law and its experimental verification. So a thin wire which stretches like a spring has a length which stretches like a spring has a length L length L, and area of cross section, A, area of cross section A. Okay, second point, a pan and a pointer, pan and a pointer are attached to the free end of the wire. The pan and the pointer are attached to the free end of the wire. Over the third point, the extension produced. Suppose if I keep the weight here, what will happen? The wire will extend, yes or no? So the extension produced is measured by a vernier scale. So what is the scale? Vernier scale. The extension produced is measured by the vernier scale arrangement. Understood? Now, what will happen if I keep the weight here? This wire will elongate. Why it is elongating? Because this weight will produce a force. Yes or no? That force will pull the wire downwards, or the force will elongate the wire. So write down, when a load is placed in the pan, a stretching force is produced. The stretching force I am going to keep it as capital F. The stretching force is produced. So because of this stretching force, what will happen? The wire also will change its length. It will elongate. Okay. So the elongation is produced. In the wire. It is denoted as delta L. Okay. Now this delta L, the elongation produced on the wire, okay, is delta L. This force, okay, F is the force and delta L is the elongation produced. Okay, so if the force is more, what will happen to the elongation? The elongation also will be more. Yes or no? If I add more weight, what will happen? The wire elongation also will be more. Okay. So this force is directly proportional to the elongation. That means what? If the elongation, if the force is more, the elongation of the wire also will be more. What will happen to the area of the wire? First, if the wire is like this, this is the area of the wire. If it elongates, what will happen? It will become like this. Yes or no? So what is happening to the area? At first the area is more. When it elongates, the area is becoming less. So if I apply force, the area is decreasing. So this force is inversely proportional to the cross-sectional area. Force is inversely proportional to the cross-sectional area. So this force and elongation, I can represent it with the help of the graph. Okay, this force and elongation I can. So I am giving one force. Force means I am keeping a weight. Okay. So for that, how much elongation is produced? Delta L. So if I plot the graph, I will get a straight line. So from this I can find out the slope. I think you know how to find out the slope. What is the formula for slope? slope is equal to y2 minus y1 divided by x2 minus x1. Okay, so this is y2 value, y1 value, this is x2 value, x1 value. The slope will give the force value. Okay, how much force? So we will delta L is equal to the slope value into force. The slope value into force. Okay, so now what I am going to do is I am going to multiply and divide by volume. Okay, multiplying and dividing by volume. Multiplying and dividing by volume. So what I will be getting if I multiply and divide by volume? What is the formula for volume? Okay, let me write. Delta L divided by V is equal to this side I am going to multiply and divide by volume. So F into slope is equal to delta L into this side I am going to multiply by volume and I am going to divide it by volume. Okay, so what is the formula for volume? Volume is equal to side into side into side. Yes or no? So volume V is equal to side into side into side. Side into side I can write it as area and I can write this side as length. So instead of volume I can substitute AL. Instead of volume I can substitute AL because side into side is area and the side is length. So area into length is the volume. So this I am going to substitute in this formula. So I will get force into slope is equal to AL divided by AL into delta L. Okay, so what I am going to do is I am going to bring this slope to the denominator. Okay, and I am going to bring this area to the denominator this side. So what I will get, F by A is equal to L, okay, into delta L divided by slope will come this side, slope into L. Like this I will be getting. Yes or no? Slope into A into L I will be getting. Slope into A into L I will be getting. So this L slope A, this is a constant. Okay, that is L by slope into A is a constant. Why it is a constant? Because length of the wire we know. Okay, area of the wire we know. And slope value also when I will get a number. Okay, it is a constant. Okay, so if I want to remove this constant and equal to sign, it will become a proportional sign. So I will be getting F by A is proportional to delta L by L. F by A is proportional to delta L by L. So F by A is nothing but your stress. Okay, so it is proportional to delta L by L is nothing but your strain. Okay, already we have discussed what is stress, what is strain, what are the types of stress, what are the types of strain. Okay, so stress is proportional to strain. Okay, so stress is proportional to strain, but this should be within the elastic limit. Elastic limit means what? Even after it elongates, it should be able to regain its original shape. Okay, that is only called elastic limit. So this is applicable only within the elastic limit. If it crosses the elastic limit, it will not regain its original shape. Okay. So with the help of Hooke's law, I have found out that stress is proportional to strain. So now I am going to draw the graph for that stress and strain. Okay. So that graph is called as stress strain profile curve. Stress strain profile curve. Okay. So when you do the experiment, okay, when you draw the graph for stress and strain, you will get the graph like this only. Okay, so the graph is drawn by taking the strain. The strain is taken in the x-axis and stress is taken in the y-axis. Okay, so when I draw the graph, how I will be getting the graph? Okay, so this point I am naming it as O. Okay, so draw the curve properly. It should be like this. So O, this point is A, this point is B, this point is C, this point is D, and this point is E. So I can divide this curve. So if I do the experiment and if I plot the graph between strain and stress, okay, I will be getting a curve like this. So what is the name of this curve? Stress strain profile curve. Okay, so I am going to divide this into 5 parts. So first part is OA, the next part is AB, then BC, then CD, and the last part is DE. So each part is having a name. Okay, so the OA is called as proportional limit. Proportional limit. AB is called as the elastic limit. Okay, and these points BC to B to D, okay, this point, that is B to D, this part is called as ultimate stress point. Ultimate stress point. And E. After this also, if I give stress, what will happen? The wire will break. Okay, so this point is called as the breaking or rupture point. Breaking or rupture point. So first I am going to explain the portion OA. Portion OA. So what is this portion OA? So I am getting a straight line. Yes or no? So straight line, how I had drawn a graph here. The same way I drew a graph like this. Yes or no? That side. So same way I am getting a straight line. So if I get a straight line means what? This portion, it obeys the Hooke's law. It obeys the Hooke's law. It obeys the Hooke's law means what? The stress is proportional to strain in this part. Okay, so as you can see, you are getting a straight line. Yes or no? The stress is proportional to strain. So this point A is the limit. Okay, this point A is the limit. After this point A, I am not getting the straight line. The straight line is deviated. Yes or no? So up to this point A only, the stress will be proportional to strain. So after this point A, what will happen? The proportionality will break. So this point is called as the proportionality limit. Okay, so that is why it is called as proportional limit. Okay, so the point A is the limit for this proportionality. The point A is the limit for this proportionality. So above this point A, what will happen? This Hooke's law will not be valid. This Hooke's law is not valid above this point A. Now the next portion AB. So AB, you see the point, the line has deviated. So the line has deviated means what? Here the stress is not proportional to strain. The stress is not proportional to strain. That means what? Hooke's law is not valid here. Hooke's law is not valid at this point. Okay. So this point B. So this point B is called as the yield point or the elastic limit. So stress will not be proportional to strain, but the elasticity will still be there. Above this point B, what will happen? The spring will lose the elastic nature. Elastic nature means what? Even if I stretch, it will not come back to the original position. So the point B is called as the yield limit or the elastic limit. Yield limit means up to this point only I can yield the original shape. After this I cannot get the original shape. Understood? So the next portion is portion BC. Portion BC. So above this B, what has happened? The elastic limit has crossed. Okay, so from B to C, if I apply the force also, again the wire will not regain its original position. Okay, so in B to C, when I increase the stress will increase, but the wire does not regain its original position. The wire does not regain its original shape or original length. Okay, so that is what is BC. Now the next one is C to D. Portion CD. This portion CD, you can see the graph is again, it is taking a hike. Okay, graph is again taking a hike means in this portion only the maximum stress, okay, the maximum stress or the breaking stress is applied. Maximum stress or the breaking stress is applied. Okay, so this stress will destroy the tensile strength of the spring. Okay, tensile strength means what? The strength which is present inside the spring, that will be destroyed. Okay, so at the point D, what will happen? The spring will start to break. Okay, at the point D where the maximum stress is there. Okay, this point D is the maximum stress. So at this point, what will happen? The spring will start to break. So this point D is called as the fracture point. It is called as the fracture point. Okay, fracture point. Okay, so DE is the portion. DE means already the stress has gone and the wire has already broken. Okay, so DE is the breaking point, or this wire has already ruptured. The wire has already ruptured. Okay, understood? Clear? So this part B, C, D, E. Okay, so up to O to B, what is happening? Up to O to B, the wire is having the elasticity. Yes or no? So the portion from O to B. O to B means from O to B. From till this portion, the wire is having the elasticity. So this portion O to B, it explains the elastic property. It explains the elastic property of the wire. So after this B, this wire is losing the elastic property. So this portion B to E. B to E means B, C, D, E. These portions, they are explaining the plasticity, plastic property of the wire. They are explaining the plastic property of the wire. Plastic means what? It cannot be stretched. It will not come back to the original shape. Okay. So this is about the elastic property and plastic property, that is also is explained by this Hooke's law. Okay, so understood what is Hooke's law, what is the stress strain curve. So the remaining things we will continue in the next class.